I've removed the left hand side tailgate clamp assembly. I don't know what the proper name is. There's the aviation lock on its stainless steel lanyard. You can see there's plenty of rust everywhere. There are two screws down here which seem to hold this little pocket in place. There's a spring-loaded pin, captive pin there, which probably means you can take this top cover off. The intention is to get it shot blasted, re-powder coated to make it look smarter. The trick to getting this tailgate locking clamp apart is, you'll see there's a bush inside here which actually is a through bush, comes out on the other side and clamps around this point here, so it locks it in place. So by tapping this sideways you can push the bush far enough to the right so it releases. That was relatively easy to get out. Just note there are two spacer washers on here by the side. Those come out. You can see where they were pressed against on the inside of this housing here. Just tapping it sideways, so if that's your mechanism in here, you just literally put something on this side of the mechanism, just tap it to the right. That'll push these bushes, which I'm going to remove, out, and they look like they're spring-loaded bushes. We're going to tap those out so we can get this powder coated. The other problem that we have, there's a rubber shock absorbing boot that sits inside here which looks like it's been bonded in, so somehow we're going to have to unglue that. And around here there are two cap head hex screws at the bottom there which lock it in place. We'll replace those ones with stainless steel, and we'll have to take this boot out. The screw that holds the towing ring in place is really hard. It looks like that could be a nylock on there. I can't get enough purchase with just a spanner and two spanners on there, so I may have to remount it on the vehicle just so that I can release it. I'm making a note of the position of the flying aviation bolt. One further problem we're faced with is that this looks like it could be riveted in place, or these are special screws that hold this part in there. Obviously to get this powder coated we're going to need to take this mechanism out. I'm not sure I'm going to do that. I've got no idea of the construction of this. That's the next puzzle. These were the two split bushes that mounted. I don't know if it's relevant, but the three little indents on there went internally into there. You can see the hole is slightly undersized, and when these push in you're actually locking this against this bracket like that, so that it kind of locks it in place, and on the other side just floats. Why they didn't do both sides I don't know, but that's the way it works. We'll give those a clean up later. I can see that this black rivet is not part of the mechanism, i.e. it goes through this part of the mechanism. So whether or not they've screwed these in and just tightened them up, there's a larger one this side and a smaller one on the other side. There might be some kind of special screw or even some kind of special rivet. I'm not sure how we're going to get over that one. It's a mystery. No doubt I'm going to chew it up to pieces trying to find out how it gets in there. Could just be a metal bar that's been peened over. Don't know. Quite clever. The bolt on the gate through the D-ring on the tailgate has got two very flimsy looking washers. Look a bit worse for wear. Does indeed look that nut is some kind of nylock, although you can't tell. The washers have been rusting and have caused it to be difficult to move because of all of this rust on here. So our only problem, this D-ring is easy to get shot blasted and re-powder coated. This so far is easy. Note there are some recesses on here. They're like a recess for a washer, and it's only just big enough for this washer. Whether or not we can get any more washers exactly that size I don't know. So what we're going to do with those I'm not sure. Be nice to get some stainless ones. The bolts also have a pre-washer on them, pressed on. Anyway, those bolts I have some similar. The remaining problems are this little rubber insert here, which I'm going to try and get off with a Stanley knife, and taking that mechanism apart. Once I've done that, then the left hand side of the tailgate will be ready to take to the shop to get them treated. and then we should be looking good. This is a tricky item. It's the tailgate catch, right? And if you look at it, you've got a pin that goes through to hold the spring mechanism in place. Now it's been peened over on one side. You can see I've actually filed the peening off just so I can release it, but it's held in under spring pressure, and I'm going to tap the shaft out. What we're going to do with it after that, I don't know. Maybe repeen it somehow. Let's see if we can get the shaft out. To make life a bit easier, and take the spring pressure off the shaft because it pushes against the actual catch itself. You find it very difficult to tap out the shaft. So putting a cable tie on there, pulling it tight, relieves the spring pressure just enough. Okay, I've tapped out most of the shaft, and here it comes. There's no spring pressure, which makes life much easier. Hard to do while you're holding the camera. In fact, I'm going to have to put it down and just give it a little tap through. The locking block is somewhat more difficult. We've got a rubber boot that looks like it's pretty heavily glued in. Not quite sure how to get that out. I'm going to try and cut it away with a Stanley knife, but don't want to damage it. I've removed as carefully as I could the rubber stopper that fitted inside. I've put 2 bolts in there to keep the threads clean for when it gets powder coated. But there's the rubber stopper. A lot of glue is still stuck onto the stopper, but I found a Dremel with a nice abrasive pad on there. Actually quite neatly takes off all of the surface glue. So I'm going to resurface the whole of that stopper and make it ready for glue. So when the unit comes back from powder coating, I will bond it in there with some kind of rubber glue. Very good rubber glue, the best I can find. This was the glue I used to reattach the rubber sleeve that fits inside the latch. It's called EvoStick Performance Technology Multi-Purpose Time Bond Non-Jet Contact Adhesive. What I did was select something that glued rubber to metal, and the most important thing I feel when doing this type of work is to make sure that you completely remove any contaminants from the surfaces. So use isopropyl alcohol, IPA, to clean them down. Make sure you've got all the old glue off the rubber boot, and then make sure you apply some pressure to the surfaces while it's bonding. And I have to say that mine has been on for 3 years and it's as good as the day it was manufactured. There's no reason why you shouldn't be able to achieve exactly the same result. Here is the latch mechanism, which is now 3 years old. You can see there's very little corrosion on it at all, if any. You can see the what I call the rubber shock absorbing boot that fits in there was glued in, and that's still in good condition. Everything is still almost like it was when it was brand new, or brand new from being shot blasted. Going to the left side here, we can see the screw that I fitted to retain the original rivet pin that was in there. As you can see, all of the parts have got stainless steel on there, and I regret the day that I ever put any kind of ordinary mild steel washers on anything. I didn't have stainless for everything. On the hinge you can see everything was nicely powder coated. I've got a little bit of rust forming here where it bumps to a stop. I don't see how you can avoid that. This part here is the lock-in screw, which is either M3 or M4. I will try and take it out and just check it. You can see that I didn't have a stainless steel washer on there and it's rusted. It's just stupid putting mild steel on. That's the grease point nipple, which needs replacing. It's also rusted, but everything else was stainless. As for the carrier, you can see everything still looks good after 3 years. No signs of rust there. Everything is still cool. The screw threads here are a weak point because you can't get those powder coated. And the other weak point is this point here, because somehow water gets inside the frame and drips out this little hole here, which I tried plugging and putting a stopper in, but the rust still forms inside. So I'm going to have a major think about what to do about this, maybe fill it with some kind of filler, but I don't know how you stop the water getting in, and that's something that I need to look at. I lost the footage of the powder coated parts and also the block with the rubber boot glued in and everything just gleaming brand new stainless steel. This part here was the original hinge taken 3 years ago, and you can see the carrier and the hinge and the shaft that goes down into the hinge. This is a picture of just the end of the carrier with the shaft on it that goes into the hinge. You can see at the bottom of the shaft there is a groove, and that's where the screw that goes through the side of the hinge screws into to stop the shaft from being pulled up. Here is a section of just the hinge which the shaft drops into. You can see it's filled with grease, looks a bit gunky in there, and on the top you can just see the outline of the seal that's in there. I'll try and highlight this a little bit extra. On the very top you can see there's a protrusion sticking up, which is to stop the carrier from rotating too far. Here is an approximation of the carrier pivot joint assembly. If we take a look at the exploded view, we can see the components inside. You can see a section of the carrier itself. Then there's a seal which is comprised of a brass ring and a rubber insert, some form of phosphor bronze bearing which we have no details about because it's a press fit item. Then you have at the bottom here a small screw which locks the pivot insert in place so that you can't lift the carrier out. If we take a look at a cross section through the pivot assembly, you can see all the major components. There is the seal, the phosphor bronze bearing, the locking screw, and this hole is for the grease nipple. So I drilled the rivet pin shaft and tapped it M3 and fitted an M3 by 6mm long, dome-headed, stainless steel cross-cut screw. The locking screw from the hinge is an M6 by 16mm cap head socket screw, stainless steel, but notice I've turned down the end there so that locks into the shaft's groove, so it locks it in place. So that just goes in there like that. And I'm sorry to you Americans for using metric sizes, but this car is mainly metric. There we go. If you are getting the complete frame bead blasted and powder coated, don't forget to mask off the pivot shaft because you don't want them spraying or bead blasting that particular item. Give them special instructions to avoid that and tape off the area just to make sure. Quite important. Here is a CAD representation of the seal that's fitted on the shaft. You can see that there is a brass ring and a rubber insert. Now if, like mine, your rubber insert was disintegrated or the brass ring even damaged, if we zoom in on a section through the pivot, we can see that in place is the original seal, which is highlighted in gold, and for the moment I've just put a visualization of the O-ring around it. If we remove the seal from view and then just slide the O-ring into position, you can see if we keep the original brass ring and remove the rubber insert and then replace it with an O-ring, it's a pretty good fit. The brass ring of the seal will help keep the O-ring in place, but if that's been damaged, you may wish to select a slightly thicker O-ring, maybe 5mm if one is available.